the Ochem Guy.
Phil Nye the Ochem Guy.
Phil Nye the Ochem Guy.
Ochem rules.
Phil Nye the Ochem Guy.
Melting point is a property of solids.
Phil Nye the Science Guy.
Recrystallization is now complete.
Phil Nye the Ochem Guy.
Hey fellow science nerds, it's me, Phil Nye, lesser known son of Bill Nye. Don't believe me? Here's a picture. Don't worry, it's legit. I studied organic chemistry in college so I can make this show and teach you all about what I know. Today's episode focuses on chemiluminescence. You may be asking yourself, what is chemiluminescence? Let's go find out.
Hi Phil, welcome to my humble abode. Let me tell you a little bit about the history of chemiluminescence. The earliest written records of luminescence are believed to date back to around 1500 BC. These are writings from the ancient Eastern civilizations, including India and China, which referred to fireflies and glowworms. The Greeks and Romans were the first to describe luminous organisms. The Greeks made references to sea phosphorescence. In addition, Aristotle noted weak emission of light from dead fungi and fish. One particular example of light-emitting fungi is Mycena luxaterna. Its Latin name means source of eternal light. Isn't that cool? The 15 and 1600s saw several interesting developments about luminescence, such as the first book devoted to bioluminescence, which was written by Conrad Gessner. Later, in 1634, English explorers actually avoided landing on Cuba because they thought they saw light from Spanish campfires along the shore. That light was just light from fire beetles. A few decades later, Boyle's work on oxygen paved the way for scientific explanations of bioluminescence. In the 1800s, scientists studied the chemiluminescence of iophene. The term chemiluminescence was actually coined later in 1888 by Weidmann. Most of our current knowledge about chemiluminescence can be attributed to work of scientists in the 1900s. This work began in 1901 when Du Bois published the first paper on bioluminescence and introduced the phrases luciferin and luciferase. Other scientific work in the early 1900s included reviews of luminescence reactions, energy transport mechanisms, and the characterization of the luminescence of luminol. Look, Phil, this is a luminol reaction using copper as a catalyst. Would you look at that luminescence? Fascinating.
Wow, that was fascinating. I'm sure you all took notes because there will be a quiz later. Anyway, that was chemiluminescence back then. What about our particular reaction, the synthesis of luminol? Please, consider the following.
Welcome to Consider the Following with Sri Josula. So here we're going to examine the synthesis of luminol. Luminol is a compound that has many practical applications in chemiluminescence. It starts out as 3-nitrophthalic acid, reacted with hydrazine and heat to result in 5-nitrophyl hydrazide. Still an aromatic compound that has electrons and can have excitations, but it's still not chemiluminescent. You still need to further react it with sodium dithionite to result in luminol. But luminol, it's a very stable compound, and it's able to be stored for long periods of time, but it's not chemiluminescent still. You still need to react it with hydrogen peroxide and hydroxide in order to produce a luminescent compound in an excited state. So let's look at the mechanism. It's a little bit exhausting. Cue fast forward scene. That was exhausting, you know? Here, we finally end up with 3 amino oxalates in an excited state. An excited state, it's kind of like a baby, you know? You feed it lots of candy, and eventually you get a baby that's really hyper and energetic, and you don't know what to do with it. It's just all over the place. So let's see what's going on with these excited states and this chemiluminescence.
Yeah, well that's great and all making luminol in the lab, but that doesn't really help us in the real world. So, let's look at some practical applications. Just got a call about a murder. Let's go check it out.
Oh, Phil, I'm glad you're here. I was just about to explain how the body got here. See, we knew the body was dragged into this room, but we couldn't tell from which direction. Perk cleaned up, but not well enough. See, all I had to do was mix a solution of luminol, hydrogen peroxide, and sodium hydroxide, and spray it on the investigation area, and even the smallest trace of hemoglobin in the blood will act as a catalyst in the luminol and cause it to chemiluminesce. Let's check it out.
Hit the lights.
The chemiluminescent proteins and molecules found in nature are called luciferins. They are used for a variety of purposes such as attracting mates, like in fireflies, and producing light in otherwise lightless conditions, like the crystal jellyfish which lives in the deep ocean. Geneticists have been able to transfer the genes responsible for this bioluminescence into engineered plants and animals for novel purposes such as bacteria that luminesce when exposed to harmful radiation or certain toxins. In the future, there may be Christmas trees that give off light on their own, crops that luminesce when they need water, or highways that are lit by bioluminescent trees instead of streetlights.
This is a glow stick. Glow sticks were inspired by the firefly. They contain hydrogen peroxide and diphenyl oxalate, and when they react, they excite a dye which drops down in energy, releasing light. Hydrogen peroxide is used because it doesn't release heat. If it released heat and light, that would be fire, and fire is not good. Glow sticks are used for safety devices, military, law enforcement, and even for having your own personal rave.
Let's rave.
Shake that.
Thanks for joining us. Hopefully it was educational for you. I know it was for me. Join us next week. We're going to talk about the ovulation cycles of chimpanzees and also why frogs are green. So you won't want to miss that. Until then, this is Phil Nye saying peace, love, and Ochem.